the reason why we're doing this linear approximation is that in the future we will be able to turn something complicated like this into something simple like this. So rather than having to work with this, we would then work with this. It's a lot simpler. Or when given something complicated like this, we can work with we can use linear approximation to turn this complicated thing here into something a lot simpler. This thing here. But don't worry about this. This is for the future. Okay, but in this video, I'm going to give you I'm going to give you an example of linearization here. So here the question is saying find the linearization of this thing here at x equals 3. So what that means is really you can just think of this question here as asking you to find the equation of this tangent line that goes through x equals 3. That's what it's asking you. This thing here is exactly the same thing as it's asking you to find the equation of this tangent line. That's what it's asking you. So in order for you to find out the equation of this tangent line here, you will need to know the gradient at this point here. So to find out the gradient, we would need to differentiate this. Okay. Once you've differentiated this, you can find out the gradient at this point, and then you need to know the coordinates at this particular point. Well, the coordinates at this particular point here will be 3, comma, and then you put this 3 into the original function. So that will be 4 square root of 4. That would be 2. So the coordinates at this point here will be 3, comma 2. Okay. So once you've got your gradient, then you can work out the equation of this tangent line. So basically, this is asking you to find the linearization of this thing here. So that's you finding out the equation of the tangent line. So the first step is to find out the gradient at this particular point. So the first step is to differentiate this. Okay. So start out with our f of x here, but visualize that square root thing as to the power of a half. So differentiate it, blah blah blah, differentiate it. So that will then give you this. So that's us differentiating it. But then we need to know the gradient at that particular point at x equals 3. Now we need to know the gradient at x equals 3. So this is our derivative here. So if you want to know the gradient at x equals 3, then you need to put 3 into this thing here. So that's you putting 3 into there, and then that will give you a gradient of 1/4. So what that means is, if you look at the graph here, what that means is this is our tangent line here. We now know the gradient right at this point here. Right at this point, the gradient will be 1/4. Okay, so that's what it means here. Okay, so start out with your function here, and then differentiate it. That will then give you this. But then you would need to know the gradient at that particular point at 3. So you would put the 3 into there to find out your gradient at x equals 3. So what we've got so far here is this. We've got our function here. We've differentiated it, and blah blah blah. The gradient at this particular point here is 1/4. We know the coordinates at this particular point here. So our linearization. So this fancy symbol here is really the equation of that tangent line here. So this is saying the equation of that tangent line is given by this thing here plus this thing here. Well, basically, just this seems really complicated, but really what it boils down to is that you know the gradient at one particular point, and you know it passes through this particular point here. So therefore, you should be able to come up with an equation for this line. Well, the equation for this line is given by this. Okay. So hang on. So it's saying the equation for that tangent line is given by this here. Okay. So what that means is, well, looking at this here, f of 0. Well, f of 0 is you putting f of x0 here. Well, this is your x0 here, x0 here. So if you put this into this thing here, that will, well, f of 0 is really this point here. 2. Okay, and then the derivative here at that particular point is what we just worked out, a quarter here, and then this here is 3. Okay, this box here is f of 0, so it's really 2 here. So hang on, so the equation of our tangent line is given by this here. Okay, and then that will then give you this. So now just work it out. So this box here is really 2. This derivative here is really this quarter thing here, and then well, you just follow it through, and so this is this here is really the same as the equation of our tangent line here. Okay, so that then blah blah tidy up. So this times this times this, that will then give you this, and then it will then give you this. Okay, this is the thing that makes it complicated is because of this bit here. It looks really complicated, but really it boils down to you. All you need to know is the gradient at this particular point and the coordinates at that particular point. Then you can work out the equation of that tangent line. But it's complicated because this thing here looks complicated, but it boils down to you just finding out the equation of that tangent line here. Okay. Well, anyway, just follow it through, and then your linearization here, which is just a fancy name for the equation, your tangent line. Okay. So when you get a graph plotter and plot this line here, this straight line here, it will then look like this blue line here, and you see this is our linearization of our f of x. So earlier we had a f of x here, which is given by this red line here. Okay, given by this red line here. This is the blue line here represents our linearization here, and you see. Sorry, hang on, my computer.